Assalamu alaikum. Yes, children, in the previous video we completed second theorem of Quadrilateral chapter. Today we shall do some more theorems. First exercise of this chapter has 8 theorems. 2 of those we have already done. Out of the 6 theorems, we may be able to do 4-5 theorems today. Let us see where we shall reach finally. Let us begin theorem number 3. The statement of the theorem you have on the textbook. This theorem is converse of theorem 2. Theorem 3 is converse of theorem 2. In theorem 2, we were given a parallelogram and had to prove opposite sides are equal, both pairs. Now, contrary to this, in this theorem, we will have to prove this quadrilateral is a parallelogram. And we will be given that its both pairs of opposite sides are of equal length. And then remember, in the theorems, wherever you will have to prove the parallelogram, the proof will follow only when you fulfill the condition of definition. So therefore, to prove this is a parallelogram here, we'll have to prove its opposite sides are parallel, because definition says a quadrilateral is a parallelogram if its both pairs of opposite sides are parallel. In the theorems, remember, you can prove parallelogram only by using definition. Diagram of this will be same as of previous theorem. A quadrilateral is there. Since we have to prove this quadrilateral is a parallelogram, we will draw the shape of a parallelogram therefore. But right now we'll call it only a quadrilateral. We'll not call it parallelogram. We have to prove that. We'll call it a quadrilateral. Let us name this quadrilateral A, B, C, D. And then, what is given to us in this? That its both pairs of opposite sides are of equal length. So, AB will be equal to CD. This is one pair. BC is equal to AD will be the second pair. We know it. Now, we have to prove it is a parallelogram. Remember, given is they are equal. Opposite sides are equal, not parallel. We have to prove it is a parallelogram, and as I said, we will prove that its both pairs of opposite sides are parallel, because that is the definition of parallelogram. And to prove that, in construction, we'll join A to C. One of the diagonals you have to draw. Well, quickly you write the given. A quadrilateral ABCD in which AB is equal to CD and BC is equal to AD. That is the given part of this. Then you write to prove ABCD is a parallelogram. Then you have to write construction, join A to C. Here now I give you the proof of this. For the proof of this theorem, again we'll prove the two triangles which are formed there are congruent. But this time the congruency rule will be different than what we used in the previous two theorems. In both those two theorems, the rule was same. Here it will be different. In the two triangles that you have in the figure, you can easily see AC is their common side. So that will be one of the elements we'll use. Then we also know AB equal to CD, it is given to us. BC equal to AD, that also is given to us. Therefore, the two triangles will be congruent by using SSS congruency rule. Let us prove. You write in triangle ABC and triangle ACD. We have AC is equal to AC, common side is the reason. AB is equal to CD. This is given to us. BC is equal to AD. This is also given to us. With this we can say the two triangles are congruent. Therefore triangle ABC is congruent to triangle CDA. SSS congruency rule. Well, yesterday also I said I did not write ACD here, alphabetical order I did not write, as I wrote earlier here. I did not write ACD here because in writing the congruency, when you write symbolic representation of is congruent to, in case of second triangle you have to write corresponding vertex in corresponding place. Corresponding vertex of A in this triangle is C in this second triangle. Then B is D, C is A. So therefore it becomes CDA. The triangles being congruent will apply CPCT then. According to CPCT, angle B will be equal to angle D. Angle at this vertex C will be equal to angle at vertex A in the second triangle. I have put single dots. Just now I said corresponding vertex of C of this triangle is A in that triangle. So therefore those angles you have equal. This angle at A vertex will be equal to the angle at C vertex in the second triangle. 3 pairs of angles. Out of these we need only 2 for proving this. We need not write angle B equal to angle D. That will not help us. So we will not waste our time. Therefore, according to CPCT, angle BAC is equal to angle ACD. It is CPCT. I have so far used one pair of angles. And then find the relation between these. This is the first angle. This is the second angle. These are alternate interior angles. And we have already read when alternate interior angles are equal, lines are parallel. Right there. But this is a pair of alternate interior angles. But this is a pair of alternate interior angles. Therefore, AB is parallel to CD. We got one pair of opposite sides, therefore parallel. But remember, to prove this is a parallelogram, you have to prove both pairs of opposite sides parallel. And second pair of opposite sides parallel we'll get from the second CPCT result. So far I have used the angles with 2 dots. There is another pair of angles with 1 dot. We write also. Also, I will write here on the top. Also, angle BCA is equal to angle CAD. For this also you write in the bracket CPCT. As we wrote here, CPCT. And then what did you write? This is a pair of alternate interior angles. Likewise this. This single dot angles, again these are alternate interior angles. So write for this also. This is a pair of alternate interior angles. Therefore, BC is parallel to AD. Second pair of opposite sides also we thus got parallel. And when a quadrilateral has both pairs of opposite sides parallel, that quadrilateral is called a parallelogram. So let us conclude, therefore, ABCD is a parallelogram. In the bracket you will write definition. Write a definition in the bracket. That completes our theorem number 3. This theorem was converse of theorem 2. Now theorem number 4. Theorem 4. Theorem 4 and 5 are also converses of each other. 4 and 5. So let us first prove theorem 4, then we'll move to the theorem 5. Statement of the theorem you have on the textbook. In a parallelogram, opposite angles are equal. Like theorem 7.2 also, we have the similar statement. There it was there also in a parallelogram. Here also it is in a parallelogram. Therefore we are given here also like theorem 2, a parallelogram. We have to prove opposite angles are equal. In that theorem 2 we have to prove opposite sides are equal. Here you have to prove opposite angles are equal. Let us draw the diagram. A parallelogram is there. As usual, like the previous case, we'll call this ABCD. We know it is a parallelogram. We have to prove its opposite angles are equal. Angle A we have to prove is equal to angle C. Angle B we have to prove is equal to angle D. Knowing it is a parallelogram, therefore by definition, we know its opposite sides are parallel. Both pairs are parallel. AB is parallel to CD. BC is parallel to AD. We know it because we know it is a parallelogram. So application of definition there. Quickly write given a parallelogram ABCD. Then you write to prove opposite angles are equal. Then let us begin the proof of this. And the proof will begin again with definition. Knowing that ABCD is a parallelogram, definition says its both pairs of opposite sides are parallel. One by one we'll consider both those pairs. Begin. ABCD is a parallelogram. Write in the bracket given. Therefore, by definition, AB is parallel to CD. Definition you write in the bracket. AB is parallel to CD. I shall here draw a rough diagram of these two sides, AB and CD. These are the two. These we know now are parallel. And then in the diagram you can see there are two transversals. BC is one transversal, AD is another transversal. Choose one of the two. Let us consider BC transversal. So write BC is a transversal. Thus, two angles are formed there with this transversal. And the angles which are formed are related to each other. These you have read are co-interior angles. And then a theorem about co-interior angles we have proved in lines and angles. When lines are parallel, co-interior angles are supplementary. Their sum is 180. Therefore, the sum of these two angles, B and C, we can give short names because at B only one angle is formed. At C also only one angle is formed. Their sum will be 180. Right? BC is a transversal. Therefore, angle B plus angle C is equal to 180 degrees. Write in the bracket co-interior angles. Theorem about co-interior angles we have proved in the lines and angles chapter. This result will mark as first. And this first result we got when we used the pair of parallel lines AB and CD. But there is another pair of parallel sides also. I shall roughly draw that also here. These are the two. D is here, A is here, B is here, C is here. And what do we find? Again, there are two transversals. Let us use the transversal AB. Co-interior angles are again formed. Their sum also will be 180 degrees. We'll write here similarly. Angle A plus angle B is equal to 180 degrees, and mark it number 2. Having done this, we will now use Euclid's axiom. Both of them are equal to 180. In first we have is equal to 180. In second also we have is equal to 180. Euclid's axiom will be applied. This 180 will get eliminated. We'll get angle B plus angle C equal to angle A plus angle B. So right from first and second we have. From first and second we have angle B plus angle C is equal to angle A plus angle B. And from both the sides, angle B will get eliminated. The conclusion is angle C is equal to angle A. That is one pair of opposite sides. Angle C equal to angle A we proved. If you want to prove the second pair also, angle B is equal to angle D, then you will have to change the transversal in this second case. First case will remain same. Transversal we did not change there. In case of second part, you have to then change the transversal. Instead of AB transversal, you have to then use CD. Therefore, instead of angle A and angle B, you will get angle C and angle D there. Then you will find angle C will get eliminated, and the result will be angle B equal to angle D. That you will do only when you want to prove. Otherwise, you can write similarly. Angle B is equal to angle D. That completes the proof of theorem number 4. After theorem number 4, we have the converse of theorem 4. That is theorem number 5. Theorem 5 is converse of theorem 4. Look at the statement from the textbook. It is like theorem number 3, opposite of theorem 2. Theorem 5 is opposite of theorem 4. We again have a quadrilateral in which each pair of opposite angles is equal. It is given to us. We have to prove that it is a parallelogram. Draw the diagram. A quadrilateral is given which we have to prove is a parallelogram. So, we'll draw the quadrilateral in the shape of parallelogram. But we'll call this right now only a quadrilateral because we have to prove it is a parallelogram. We cannot call it right now a parallelogram. We have to prove that. A quadrilateral. In this quadrilateral, both pairs of opposite angles are given to be equal. Angle A is equal to angle C. Angle B is equal to angle D. We are given this. Opposite angles are equal. You quickly write given and to prove. A quadrilateral ABCD in which angle A is equal to angle C and angle B is equal to angle D. Then you write to prove. ABCD is a parallelogram. We don't have any construction here. You go to the proof part of this now. Proof. We'll again use the concept that I explained earlier. While doing theorem 3, I said whenever you have to prove a quadrilateral is a parallelogram in the theorems, you will have to use the definition. Later on when we go to the application part, exercise when we'll start, there we will not follow this. We can use theorems also there. Definition also can be used there. But right now in the theorems, when you are doing theorems and you have to prove a quadrilateral is a parallelogram, you have to do it by using definition. Therefore, to prove this is a parallelogram, you will have to prove its both pairs of opposite sides are parallel. AB is parallel to CD, BC is parallel to AD, because that is the definition. And to prove that, we'll use angle sum property of quadrilateral. Write the proof. We know angle A plus angle B plus angle C plus angle D is equal to 360 degrees. Write in the bracket angle sum property of a quadrilateral. Angle sum property of a quadrilateral. And then in this result, we will use the given condition. What is given to us? Angle A is equal to angle C, angle B equal to angle D. We'll replace therefore angle A by angle C because angle A is equal to angle C. And we'll replace angle B by angle D because angle B is equal to angle D. We'll get angle C plus angle D. For angle A, I wrote angle C. For angle B, I wrote angle D. Plus angle C and angle D then will remain as it is equal to 360. Why so? It is given to us. So write in the bracket given. Next I find there are like terms. Let us combine. Angle C is twice, so we write twice angle C plus twice angle D is equal to 360. Simplifying this further, 2 is common here. Let us take 2 common. Bracket will contain angle C plus angle D is equal to 360 as it is. Transpose 2 will get angle C plus angle D is equal to 360 divided by 2 is equal to 180 degrees. We proved angle C plus angle D therefore is equal to 180, and when we look at the diagram, we find the relation between angle C and angle D. These are co-interior angles. Angle C and angle D, they are co-interior angles. And according to the theorem again done in lines and angles chapter, when co-interior angles are supplementary, lines are parallel. So right, but this is a pair of co-interior angles. This is a pair of co-interior angles. Therefore, BC is parallel to AD. One pair of opposite sides we got, therefore parallel. BC parallel to AD. But to prove it is a parallelogram, you have to prove both pairs of opposite sides are parallel. We therefore need to prove even AB is parallel to CD. And to get that, you have to follow the same procedure. Again, you will begin with angle sum property of quadrilateral. But now, as you substitute, use the given results, you will not eliminate angle A and angle B. For angle A, we wrote angle C earlier. For angle B, we wrote angle D earlier. We eliminated angle A and angle B. This time, out of A and B, will eliminate only one, either A or B. Suppose we eliminate A. You will not then eliminate B. You will then eliminate D because angle B is equal to angle D. You will replace angle D then by angle B. So only one out of these angles which we eliminated earlier will now be eliminated. Let us do that. Right, again. Again, angle A plus angle B plus angle C plus angle D is equal to 360 degrees. Angle sum property of quadrilateral. And then as I said, out of angle A and angle B which we eliminated previously, only one will be eliminated. Let us eliminate A. We'll write for angle AC because angle A is equal to angle C. B will not eliminate, so we'll write B as it is. Plus C also will be kept as it is. We'll eliminate this time angle D now. We know angle D is equal to angle B, so for angle D we'll write angle B is equal to 360. So the procedure is same. Only we have eliminated differently this time. Out of the two angles we eliminated in the previous case, only one will be eliminated. A we eliminated, B we did not eliminate. Instead we eliminated D angle. This time I have twice angle C plus twice angle B is equal to 360. Again 2 will be taken common. Bracket will contain angle C plus angle B is equal to 360. Then transpose 2 will again get angle C plus angle B equal to 360 by 2. This is again 180. Procedure is same, steps are same. The only thing that changed is only one out of the two we eliminated in the previous case was eliminated now. This time, instead of that, we eliminated angle D. Look at angle B and angle C in the figure. Again, a pair of consecutive interior angles, co-interior angles. So, right, this is a pair of co-interior angles. Therefore, AB is parallel to CD. And that is the second pair of opposite sides. Earlier we said BC is parallel to AD. Now we have AB parallel to CD. And this fulfills therefore definition. According to definition, we'll conclude therefore ABCD is a parallelogram. That is according to definition. Write in the bracket definition. That completes this theorem, and I shall conclude the day here.